Okay, this is on congruence of triangles, on proving congruence. That's up to you. You can keep them in your notebook, that's fine. Before break, we proved triangles congruent if all 6 things were congruent. If all 3 sides were congruent, if all 3 angles were congruent, then the triangles were congruent. Okay, now we're going to do triangle congruence with less than all 6. Okay, and this is going to be by showing all 3 sides, side, 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 and the other thing in this section is side, angle, side. Okay, so the first thing the author goes through is postulate 4.1. Okay, and it says if 3 sides of one triangle are congruent to 3 sides of the second triangle, okay, then the triangles are congruent. So not having all 6, we're just going side, side, side. Okay, and that will be your abbreviation, side, side, side. Okay, so if draw a picture, if we have say this triangle, here's the advantage. Okay, if this side is congruent to this side is congruent to this side, and then this one is congruent to this one. If all 3 sides are congruent, then the triangles are congruent. Okay, and that's postulate 4.1. Okay, the next one the author goes through is postulate 4.2, and it says if 2 sides and the included angle, and I'll show you what that means on the picture. 2 sides and the included angle of one triangle are congruent to 2 sides and the included angle okay, if 2 sides and the included angle of one triangle are congruent to 2 sides and the included angle of another triangle, then the triangles are congruent. Now, the order that you write this makes a difference. It's going to be side, angle, side. It's an included angle. So, picture-wise, okay, draw a triangle. Okay, and label this one B, Y up at the top, and A. Remember, your angles are always uppercase letters. And label this angle C, this angle up at the top X, and this one is Z. Okay, if BY is congruent to CX, okay, and BA is congruent to CZ, okay, and angle B is congruent to angle C. So the included angle is between the two, okay, it's between this side and this side. You've got an included angle, okay, and then remember the order that you write it makes a difference. Like if I said triangle Y, B, A, if I wrote it in that order, then it's congruent to triangle, whatever you, yeah, so it's got to be in the right order. So it's got to be X, and then C, and then Z, okay? And remember, you can cycle these through. Like if I said, if I turned this around and said BAY is congruent to CZX. If I said AYB is congruent to CXC. But they have to be in the right order, okay? Now I want to go through one thing that you're going to go through in the next couple of sections. It's not going to be like we're going to be doing this for a semester, but in a couple of these sections, because of the different things that you have to go through, there are proofs. Everything we're going to do, the author does paragraph proofs, flow proofs. Everything we're going to do is 2-column proofs, but I think it's important that you see some examples. Okay, so in the book it'll say write a 2-column proof. And whenever we do a proof, they will give you information, and they usually give you a picture, and it's almost critical that you write down the given and draw the picture. Okay, so on this one, you're given, okay, segment AB, and if it's a segment, remember it's got that line above it. Segment AB is congruent to DB, and C is the midpoint of AD, segment AD. Okay, and what they want you to prove, triangle A, B, C is congruent to triangle D, B, C. Okay? Now, I think it's important that you write down that much in your notebook, because down the road you're not going to have the book. Okay? If all you have is the proof, you can go backwards and say, yeah, I can see what was given up here, and I can see what I had to prove down here, but to me it's easier if you can see the original problem. Okay, now here's the picture. Label this A, this B, this D, and this is C. Okay? Now, it tells you that AB is congruent to DB, so that ought to be marked. Okay? AB is congruent to DB. Okay? You can use one line or you can use two, as long as you can tell that they're equal. Okay? And C is the midpoint. Okay? Okay, so now we're going to go through the proof. Now, your steps, if you were doing this, don't have to be identical to mine, but you've got to get to the end, and it's got to each statement has to be a true statement as you're going there. And remember, it's 2 columns, so it's statement and reason. Okay. Now, sometimes the author splits the given up into 2. Sometimes he puts it in 1. On this one, the author used 2 statements, but you could do it in 1. AB is congruent to DB. The author wrote that as given. I could write the next statement, but the author actually put it on another line. Okay. C is the midpoint. And I don't really care if it's 1 statement or 2. Doesn't matter to me. And that would also be given. Okay. Now, if you know that C is the midpoint of AD, what do you know about AC and CD? They're equal. Okay, and they're congruent. So this would be congruent to this. Why? But why? What's the official thing in midpoint? Midpoint. There's 2 things. There's midpoint, definition of midpoint, and there's midpoint theorem. It actually goes back to page 129. It's actually the midpoint theorem. Okay, so AC that segment, make sure you have a line above it, is congruent to DC. Okay, and that is by the midpoint theorem. And if you go back, everybody look back for a minute on page 129. Go back, page 129. And if you have to, you just look it up in the back of the book, and it'll say go to page 129, all the way at the bottom. Theorem 2.1. If M is the midpoint of AB, then AM is congruent to MB. Okay? Okay. You don't have to reference. You don't have to put this on your proof. That's just information. Okay. Okay. Now, if you look, so far we have two sides. We've got this one congruent, this side congruent to this side. We've got this side congruent to this side. Okay. Where can we get another side? Yeah, this side. Isn't that side congruent to itself? If anything's congruent to itself or equal to itself, what property is that? Reflexive. Yep, reflexive. So BC is congruent to itself. Okay, BC is congruent to BC, and they call that. Now, there's different reflexive properties, and this one is actually the reflexive property of congruence. And just use the congruent symbol. Okay. Now, if that's true, okay, this is congruent to itself. Now we have all three sides congruent. Okay, so now the order that you write this makes a difference. So if I start triangle A, B, C, what's the order that I have to have this one? D, B, C. Okay, and then that is by side, side, side. Okay, you could call it. You can write side, side, side. Sometimes the author does this. I'm not going to count it wrong if you don't have the word postulate. Okay. Okay. Now you have to go back up here. Did we get them in the right order? Are they in the right order? Yes. If they were not in the right order, then you would have to rearrange them. Okay, to get them in the right order. Okay, and that's your proof. Okay, that wasn't too bad, was it? Not as bad as the first semester when we first went through. Remember, that was like, we have come a long way. That panic did not set in there. Yay. Okay, let's do another one. One more example. I want to give you enough that you have examples. Okay. Okay. Same thing. We're going to do a two-column proof. Okay. Let's say you're given RQ, segment RQ is parallel to TS. And RQ, segment RQ, is congruent to segment TS. Okay, and what they want you to prove is angle Q is congruent to angle S. Here's the picture. Draw like a parallelogram. Okay, label R up here. Label this as S. This is T. And this is Q. Okay, and I want a diagonal from R to T. Okay, now look at what's given. RQ is parallel to TS. RQ is parallel. Remember we did that with the little red arrow? These two lines are parallel. Okay. And they're congruent, so you can mark them with a line. Okay. And what we're trying to get to is we're trying to prove this angle and this angle are congruent. Okay? Okay? Now let's go through the proof. one thing you'll figure out about doing these two-column proofs, if any of you are interested down the road into going into law, these are really good. The logic and reasoning of proofs, because down the road in law, if you say something, you've got to back it up. Okay? Okay, so first thing is the given. RQ is parallel to TS. Okay, and I'm going to write this in one. RQ, segment RQ is congruent to TS. Okay, so that's given. Okay. Now, if you have two parallel lines, okay, we've got two parallel lines cut by a transversal. Okay, you got to be able to get some angles equal in there. Okay, if you look at angle QRT, this angle QRT, what angle is that congruent to? STR. These Y. You almost have to turn that picture sideways. Alternate interior. Okay, so second step. Angle QRT is congruent to angle STR. Alternate interior angles congruent. Alternate interior angles are congruent. Okay, now we've got a side and we've got an angle, and all we've got is side, 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 or side, angle, side. Where's the other side? The middle. Yep. Yep. This one right here, RT equals itself, right? That'd give us angle, or side, angle, side. Okay, and side, angle, side. So, RT is congruent to RT. Why? Reflexive. Yep. That is the reflexive property of congruence. Okay. Now, you've got side, angle, side. Okay, so fourth one, you've got triangle QRT is congruent to triangle STR. Okay, and that was by side, angle, side. Okay, if you want to say side, angle, side postulate, like I said, I won't count it wrong if you just say side, angle, side. Now, if you've got the two triangles congruent, look at the order of the angles. They have to be in the right order. So angle Q is congruent to angle S. If you have the two triangles congruent, why are the parts congruent? You remember from before break? What does that mean? Corresponding parts of congruent triangles are congruent. Okay? Once you get the triangles congruent, okay, this stands for corresponding parts of congruent triangles are congruent. So if you want to get parts of a triangle congruent, then you've got to get the triangles congruent first. And we could say, you know, if they wanted us to prove, like, if they wanted us to prove R was congruent to T, if they wanted us to prove segment QR was congruent to segment ST, we could do that. Okay. As soon as you get the triangles congruent, then you can get the parts congruent, and that's all you have to write is corresponding parts, the CPC, PC. Okay. Okay, that should be enough to get you started on the homework. Okay. Make sure you are all caught up with the notebook up to that point. Okay. And then That will be, remember, for Wednesday. Okay? Okay? Yeah.